Good morning all of you. In last video we discussed about this annual worth method and we solved some examples based on this annual worth method. So in this annual worth method, this annual worth is equal to this R. Annual worth is equal to revenue minus expenses, minus this capital recovery. Revenue minus expenses minus this capital recovery, and this equivalent uniform annual cost EUAC is equal to expenses plus capital recovery. So this term E plus CR term is considered as a equivalent uniform annual cost. So both these expenses and the capital recovery considered as a equivalent uniform annual cost. So we can, with this formula, we can find out this annual worth, and at that particular interested I. And if this annual worth is greater than or equal to 0, then we can say that this project is economically justified. So we go through some numericals. Based on this method. So we move toward this some more examples. So in this example it is given that a firm require a heavy machine which cost rupees 4 lakh and has an estimated salvage value of rupees 5 lakh. So it is a 40 lakh. So this cost of this machine is a 40 lakh and salvage value is rupees 5 lakh. At the end of the 7th year of operating life. If the firm uses the rate of interest as 18% for the project evaluation, how much must be earned by way of capital recovery so that the firm is able to recover its invested capital and earn a return on capital committed to the equipment during in lifetime? So here some investment is given 40 lakh, salvage value after 7th year, that salvage value we get as a 5 lakh. And interest rate is given as 18%. And how much they asked, how much we can earn by capital recovery so that firm is able to recover its invested capital. So what are the given quantities? Are the investment is given as a 40 lakh, salvage value is given as a 5 lakh, time period is given as a 7 year, and minimum attractive rate of return is given as a 18%. So this capital recovery we calculated like this. So this capital recovery is equal to P into this A by P factor. This A by P factor is nothing but a capital recovery factor. From tabulated. So some tabulated values. In last video we discussed about these tabulated factors. So this A by P have some factor value. Which is represented as a capital recovery. A by F is a sinking fund factor. A by P is a capital recovery factor. And for this A by P and for this A by F, we have some formula. And these are nothing but like a capital recovery factor. This is a sinking fund factor. And we find out this capital recovery factor and sinking fund factor at particular interest rate 18% for year 7 year. We find out these factors, and this factor comes as a 0.2624 as a capital recovery, and for sinking fund this comes as a 0.0824. By putting this value into this equation, we get a capital capital recovery CR. Capital recovery CR is equal to this much of value. So this is the asking quantity. So they asked to find out how much this capital recovery, at particular interest rate 18% for a particular period of time, say 1 year, or particular period of time, say 1 year. So we put all these values, and find out this capital recovery. So this example, so this A by P and A by F, again we show this table value. We go through this table value. Previously, this A by P and A by F, are represented as capital recovery factor. A by F is a sinking fund factor, and these are calculated like this. For a particular interest rate I and for a particular period of time N, we put these values of I value and time period value N into this formula, and find out this A by P factor and this A by F factor, and put into our numerical. And we can find out this particular value of capital recovery. Now, second example. In this second example, one milling machine is given having some cost value of 1 lakh and will incur rupees 2,500 rupees per year in fixed cost and rupees 1,500 per hour in a variable cost. The machine will be operational for 100 hours per year for 6 years and will then be sold for rupees 20,000. The minimum attractive rate of return is given as 20% per year. So determine capital recovery cost of machine and what is the equivalent uniform annual cost EUAC of that particular machine. So they ask two quantities. So we have these formulas. So here it is a P into investment P into A by P capital recovery factor for particular rate 20% and for year 6 year minus salvage value into sinking fund factor. This is sinking fund factor A by F at particular rate interest rate 20% and for year 6 years. Then we find out this A by P and A by F as we see in the last numerical, and this A by P this capital recovery factor comes as a 0.3007 and sinking fund factor comes as a 0.1007. We put all this value here and we will get capital recovery as a rupees 993. And annual expenses here, equivalent uniform annual cost is equal to annual expenses E plus capital recovery CR. So we already calculated this CR value, this capital recovery value CR here 993 rupees. Now we have to find out the expenses. The expenses are the 2,500 fixed values. These are the fixed cost, 2,500 fixed cost. But variable cost is given as a 1,500 per hour, and these are for the 100 hours. So it is multiplied by 100. And that we will calculate it. That will be calculated like this. 100 into 1,500 into 100. So this will come like this. As a 1,52,500. And then addition of both these expenses and the capital recovery we will give as a equivalent uniform annual cost. EUAC. So these are the asking quantity. So these numericals are a simple one with some formula. Only in this for examples, this A by P, what is meant by A by P, what is meant by A by F, that we have to remember, and that formula related to this particular factor, we have to remember. And that formula we used and we can solve this numerical easily. So this for the your syllabus, it is introductory syllabus. And they are expected to solve this some numericals based on this formula. So next point we here we go through this next point as a. So we discussed from last videos. A few videos as a present worth method, future worth method, and annual worth method. Present worth method, future worth method, and annual worth method. So we discussed three methods. By these three methods, we can say that, or we can conclude that whether this project is economical or not economical. We conclude that whether this project is economical or not economical by using these three methods: present worth method, or future worth method, or annual worth method. So we discussed three methods in last videos, and by using these three methods we can say that, we can conclude that whether this project is economical or not economical. Now we move toward the next point. As an internal rate of return method. So these methods are again used to evaluate. Or conclude whether these projects are economical or not economical. So we now in previous video we discussed three methods. Now this is again one new method, internal rate of return, and by using this method again we can conclude whether this method is economical or not economical, whether this project is economical or not economical. So this is the internal rate of return. So in this internal rate of return, in this method, these are used for the engineering economic analysis. And it is also called as the investor method. And this method, find interest rate. Now, as per name suggest, this method is used to find out interest rate. And equate this equivalent worth. This method find out the interest rate. By considering outflow, by considering cash outflow and cash inflow. These are find out particular interest rate by considering cash inflows and cash outflows. So we discuss further. So this method find out the interest rate. This method find out interest rate by considering cash inflow and cash outflow. And by equating this, we are interested to find out particular internal rate or particular interest rate. So for this method, to find out this interest rate, we use either present worth method, either future worth method, or either annual worth method. So here in this method we equate this cash outflow and cash inflow. Inflow. And for this equating this cash outflow and cash inflow, we use either present worth method, either future worth method, or either annual worth method. So here we consider as a present worth method. We can use any method, and we equate this cash inflow and cash outflow. So we consider here present worth formulation, and here they equate. So we have to interested to find out a particular interest rate I. Now this I we denote as a I dash. This is I is denoted as a I dash, and this I dash at which these two cash inflow and cash outflow are equal. This cash inflow and cash outflow are equal. So this RK implies the net revenue. RK implies the net revenue, and EK implies the net expenditure. EK represents net expenditure for the kth year. And for this condition, whatever that I dash comes, it is nothing but a internal rate of return. And that we denote as a IRR. By notation as a IRR. So if that I dash is greater than or equal to MERR, if this I dash is greater than or equal to MERR, then the alternative is acceptable. Then that particular project is acceptable. Otherwise it is not acceptable. So we find out a particular I dash value. We find out a particular interest rate value at which this cash inflow and cash outflow are equal. So by in another word we can say that this subtraction, if you move this term on the left hand side, so subtraction becomes as 0, and this is this we consider by using present worth method. So we can say that in another word when present worth becomes as 0, at that particular interest rate I, when present worth becomes as 0, at that particular interest rate I dash is nothing but the internal rate of return. When present worth becomes 0, that particular interest rate I dash is nothing but the particular internal rate of return. And this I dash should be greater than or equal to MER. So that we can say that this project is economical or not economical. So here some examples, we go through some examples and then we understand this particular method. So to find out this particular interest rate I dash, we can use any formulation. Annual worth method formulation, or future worth method formulation, or present worth method formulation. So here in this PPT we use this present worth formulation. We can use any formulation, and you can solve this. Or equate this outflow, cash outflow and cash inflow, and find out that particular interest rate I dash. For which this cash outflow, cash inflow are equal. And we can, in another word, you can say that when we move this left hand side or right hand side toward the or we move these terms on one side, we move all these terms on one side, the right hand side becomes as a 0. So in another word, you can say that when present worth becomes as a 0, this whatever that interest rate I, for a particular interest rate I dash, then that particular interest rate I dash is nothing but a internal rate of return, IRR, and generally it is denoted as a IRR notation. So we go through some numericals based on this internal rate of return. So in this numerical, it is some numericals are given here. So in this numerical, it is given doctors working in a hospital have requested a machine whose purchase will aid diagnostics of the TB patients. The investment cost will be rupees 5 lakh, and the equipment market value at the end of its expected life of 20 years will be 2 lakh, and the increased productivity as a result of the machine purchase is calculated to be rupees 17,000 per year. After extra operation costs have been subtracted from the value of additional production, evaluate that internal rate of return IRR of the machine using 20% of minimum attractive rate of return MERR, 20%. So here they given So here they given so here they given some terms. So given some quantities, they given some quantities, and that quantities are given as a investment as a 5 lakh. After some 20 years, that machine again have some salvage value. 2 lakh. Salvage value 2 lakh. Annual revenue from this machine is 70,000. And now we put all these terms into a particular formula, present worth formula. So we have to find out that I dash. So for that I dash, this present worth should be becomes as 0. Present worth should be becomes as 0. Present worth should be 0. And present worth have formula like this. Present worth have formula like this: minus P plus AR into this P by a factor at particular interest rate I. So this P by a factor is nothing but a uniform series payment. This P by a factor is nothing but a uniform series payment. Present worth, uniform series present worth, and P by F is a single payment present worth. So this P by A and P by F, these are the present worth values. This P by A calculated for uniform series and P by F is a single payment. P by F is a present worth for a single payment. So to find out this value of I in interest at I, that for particular interest at I, when present worth becomes as a 0, So to find out this particular interest at I, this interest at I we can find out by interpolation formula. This internal rate of return I, that interest rate we have to find out for particular present worth becomes, when particular present worth becomes a 0. To find out this, we use interpolation formula. So for this using interpolation, we consider relation between this present worth and interest rate I is a linear one, as a straight one, linear and represented as a straight line, and we consider for a short interval of time. This relation should be linear one. So to find out this, now look at this figure. So in this figure, on the y-axis there is a present worth. And on x-axis there is a interest rate I. On y-axis there is a present worth PW, and at x-axis there is a interest rate I. So interest rate is increasing on the x-axis as we move toward the right, and present worth increasing as we move toward the upside. So here this interest rate increases on the right hand side of this x-axis, so 10%. So now to find out a particular interest rate I, so here minimum attractive rate of return is given as a 20%. Now we consider two rates. 10% and 12%. We consider two rates, 12% and 10% and 12%. Now by considering these two rates, we can find out this present worth value at particular interest rate 10% and 12%. At particular interest rate 10% and 12%. Now we have to interested to find out this present worth value. At particular interest rate I. When this present worth becomes as a 0. Now here we consider this present worth or calculate this present worth for percentage I is equal to 10%, and for percentage I is equal to 12%. Now for 10% we have some present worth value, for 12% we have some present worth value, and we are interested to find out at which interest rate I, this present worth becomes as a 0. This present worth becomes as a 0. So when we put this interest rate I, when we put interest rate I 10% into this present worth formula, this will come as a 43,598. And when we put I is equal to 12% in present worth formula, this present worth becomes as a 1,25,672. Look at this present worth formula. Look at this present worth formula here. Look at this present worth formula here. So here in this present worth formula, look at this present worth formula. So here in this example, this annual expense is not given. In this example, annual expense is not given. So AE term, this AE term becomes as a 0. This AE term becomes as a 0. Sometime, in some numerical, the salvage value is not given. Sometimes the salvage value is not given. So in that particular condition or in that particular numerical, that term becomes as 0. So in this example, this annual expense is not given. So this annual expenses term is become 0. So in some example, this salvage value is not given. So this salvage value term becomes as 0. Like that. So we put I is equal to 10%. I is equal to 10% in this formula, and we find out that present worth value. I is equal to 12%. We find out some present worth value. Now we have two values. This first value and the second value. At some interest rate. Now when you plot on this graph, and we are interested to find out at particular interest rate I, when this present worth becomes as 0. Particular interest I when this present worth becomes as 0. So in this case, we have some higher present worth value, 1,25,000. It reduces to 43,598. We have some two interest rates, 10% and 12%, and interest rate becomes as a larger one when as we move toward the right side of the x-axis. So we consider here this interest rate as a 10 and 12% as we move on the right hand side of this x-axis. This interest rate are increases, but this present worth value should be decreases. So that at particular interest rate I, this present worth value becomes as 0. At further I% value, this present worth value should become 0. So we consider here I after 12% I, consider interest rate I, so that this present worth value becomes as 0. Now for this condition, we use interpolation formula. So in interpolation formula, we have some. In this interpolation formula, we have some two values. And for that two values, we have to find out. For these two values, we have to find out some intermediate value. So interpolation formula, we use here interpolation formula. So two values. So here consider two differences. Here we consider two differences. So for 12% and for the 10%. And at some intermediate value I. There should be present worth becomes as 0. So this 1,25,000 minus this 43,598. So this 1,25,000 value for the interest at 12%. So these values are the present worth value subtraction. Similarly, this represents as a interest rate value subtraction. So 1,25,672 minus 43,598. These are the present worth subtraction divided by interest rate subtraction 12 minus 10. Interest rate subtraction 12 minus 10. So it becomes the 2. Now intermediate I value at some particular intermediate I value, this present worth becomes as a 0. This present worth becomes as a 0. So present worth. Now particular, now here again this subtraction is for the interest rate I minus 12. Interest rate I minus 12. So interest rate I minus 12, and here also there is subtraction for the present worth values. Subtraction for the present worth values. So at I% that present worth value is 0. I% present worth value is 0. So subtraction of 0 and 43,598. So it becomes as a 43,598. Only 43,598. So by solving this we get interest rate I is equal to 13.062. Interest rate, internal rate of return I we get as a 13.062. So this will now becomes as a, and this particular 13.062% is less than 20%, which is given in numerical. That is the minimum attractive rate of return. So if this internal rate of return is less than MERR, then we can say that investment is not desirable. If this internal rate of return comes as a larger than this minimum attractive rate of return, then we can say that this investment is desirable. But if it is less than minimum attractive rate of return, then we can say that it is undesirable. So we conclude that this investment is not desirable.